Now it's going to turn out that whenever we have a circuit that either has a resistor and a capacitor, or it has a resistor and an inductor, then it's going to turn out that if you write out the equation that governs what's going on in the circuit, it's always going to be a linear first-order differential equation. Even more than that, it's going to be a constant coefficient equation. And that's what's going to happen for every single one of these circuits. And so because it turns out to be a first-order differential equation, we call these first-order circuits. And so what we're going to do is we're going to focus on how do we solve a standard first-order linear constant coefficient differential equation. Now, you may have solved this in Math 152. You definitely should have solved something like this in Math 252. And so we're going to focus, although I'll tell you right now that it's going to turn out that the homogeneous solution is this. So remember how you find homogeneous solution. You plug in your right hand side as 0, and so I'd have dx dt plus ax equal to 0. I would separate variables here and get dx over x is a dt. Integrate both sides. That gives me ln x equals at plus c. Then we exponentiate both sides, and that is a minus sign. And so then we'd have x is e to the negative at plus c. And then you should remember that trick from differential equations, where that becomes some different constant, c e to the minus at, and we'll just call that k here. And so that gives you the fact that the homogeneous solution is always going to be k times e to the negative at.